All right, good afternoon, everybody. Thank you for your time. Let's start today with a little bit introduction to Singapore Math and how our focus is very much on building a strong conceptual foundation. Now, in our curriculum framework, in the Singapore curriculum framework, at the heart of the Singapore math curriculum is problem solving. Why problem solving? Because problem solving is a high order thinking skills to bring about the desired 21st century skills. Now, in that framework, there are other features as well. So if you look at your screen, what you're looking is that these are the features that accompanies problem solving to bring about the desired outcomes of education. So we've got the concrete pictorial abstract approach, we've got the spiral curriculum approach, we've got problem solving, the use of heuristics. In this case, we focus on model method. And then eventually the last part is when we have everything else in the framework, what we want to ensure is mastery, that the children achieve the appropriate level of mastery. So let's start with the first one, the concrete pictorial abstract. What we do is we actually borrow Jerome Bruner's inactive, iconic, symbolic approach to learning. Now, this is the original definition of the one that we coined it as concrete pictorial abstract, is adopted from Bruner's inactive, iconic, symbolic. Now, Bruner believes that learning takes place in different stages. Why is that? So at every stage, children will then go through a certain level of understanding. All right, to bring about the understanding, to deepen the concept of very complex and difficult mathematical concepts. So what happens here is that big concepts are broken down into smaller ones, and we start at the concrete stage, and then after that we move to the pictorial, and then we move to the abstract stage. All right, it's the same thing. We just renamed it to concrete pictorial abstract. So why are we doing this? Like I said earlier, to uncover abstract mathematical concepts, to make it simpler. We do it in bite sizes so as to make it manageable both for teachers and students. And the whole idea is basically to bring about sense making and understanding through unconscious play at the concrete stage. And then in this concrete stage, that's when realization of something meaningful during the play actually takes place. And that's where the aha moment comes about. So this usually happens at the concrete stage. And then the pictorials, the next two stages, actually consolidates and wraps up the learning that takes place at the concrete stage. Now let's take a look at each stage here, right? So at the concrete stage, physical objects are being used. Why physical objects? Children find it really hard to imagine in their heads. What they need to have is that they need to have physical objects to move, to hold, to touch. So, for example, if they take a cube and then they hold it and they go like, okay, this is one. They take another cube and then they count again, and then they go like, I have two. Then they take another one. Then they take another one, so they can count physically with every object that is in front of them. That's how the sense making starts to kick in. At this stage, we don't encourage children to do abstract thinking. So here we have a lot, here at this stage is strictly the use of concrete objects. Now, with home-based learning that's going on now, what we have is we actually have the use of virtual manipulatives, somewhat similar. The children can actually move the objects with the cursor, with the computer. All right, not as similar, but that's the closest, the virtual manipulatives, but they bring about the same objective, the same outcome for the concrete part of the CPA approach. All right, so my colleague will cover that part in a while. Next, we move on to pictorial. What is the pictorial stage? Now, as mentioned earlier, concrete stage is where the sense making starts. So a big, difficult or abstract concept starts in bite-sized amount. So for example, there are some photographs after this. There is an example of addition with renaming or subtraction with renaming. So instead of doing subtraction, the whole thing, we break it into small, into bite sizes. So for example, in this case, with addition with renaming. So that's when the children are given objects, and that's when the sense making starts at the stage here. Now, what happens at the pictorial stage is where the experiences at the first stage, which is the concrete stage, is actually captured in pictorial form like this. All right. Now, it's actually a recording of what happened at the concrete stage. Now, this recording comes in visual forms. So if a child completely understands what happens at the concrete stage, then the pictorial stage will be illustrated correctly. But if the child does not understand what happens at the concrete stage, you can see the gaps in the pictorial form. Then you know that the child has not understood exactly which part of the learning that has taken place at the concrete stage. All right. So that's the beauty of the CPA approach. It's sort of like gives you a rough gauge of whether the understanding is there even before you complete the whole process. The last stage is the abstract stage. The abstract stage is where we start introducing numbers. Now remember, at the concrete stage, children just make sense. They know what is 1, they know what is 2, they know what is 3, but they only learn to write the number 1 at this stage here. Like for example, the symbol for, the symbol of addition, the symbol for equal sign. All right, so this only takes place after the first 2 stages have been completely understood. Now, this is actually taken, these are images taken from a video. I'm not playing the video today because we're given a short time. So what I did was I took snapshots of the video to show you. Now, these are the concrete materials that I use. Popsicle sticks. All right, so then what we have is we lay them. What I did here was to add 45 to 27. So you could see that I grouped the sticks into 110 of 10 ones. And then these are my loose ones. They are the ones. All right. So then what happens is when the children, can you see? So I count the 5 ones and 7 ones, I get 12. But what I can do here is I can see, you can see that I group my 10 ones into 110. Now with this, I realize that my 110 cannot stay in the ones column. It has to move to the tens column. So children are able to not only see, but they could move it. So they understand why we are renaming. So this is what we call renaming 10 ones into 110 to the next column. So what am I doing here? I'm actually borrowing, not borrowing, I'm actually using or tapping on their prior knowledge. What prior knowledge am I tapping on? I'm tapping on number bonds because here there are actually 12. 12 is made up of 10 and 2. So that's the first prior knowledge that I use, that I get the children to use. The next prior knowledge that I use is that the use of place value, the ones and the tens. So tens should go to the tens column after being regrouped. So by doing this, what I'm doing is I'm actually expanding, I'm tapping on what they already know to learn something new. So this is a pictorial representation. Everything is the same. It's just that I take away the physical manipulative and I replace them with an illustration. So in this case, I just want to do sticks. So each sticks here represent tens and each stick here represents the ones. So if you could recall, like I said, this is a recording, or you recall what happened at the concrete stage. So you've got 10 ones here. 10 ones is actually equivalent to 110 here. But the 110 cannot stay in the same column because it should go to the appropriate column. So I have to move it over here. So once I move it, it no longer stays in the ones column. So you can see that as long as the children can show this, you know that they have understood what they were doing at the concrete stage. The next stage is where we start introducing the abstract form. So the abstract form is very, very, very sensitive because you don't want to introduce that at the very start of the lesson. Why? We want children to be comfortable, not intimidated. We want children to feel secure when they're learning something difficult. We want them to have this assurance that it's okay to make a mistake, but let's just explore, let's just discover. All right. So once they are into it, that's when they have reached certain level of understanding, that's when abstract form is introduced. And this should usually be at the very last part. So what I do here, again, like I said, I tapped on number bonds and place value. So you could see that 5 and 7 gives me 12. 12 is actually 10 and 2. What did I do? I regroup this into 110, so it goes into the ones column. In doing this, I use the word I regroup the 10 ones into 110. I don't use the word I carry over. Carrying over is a wrong mathematical language to use for the children. So the book actually tells you exactly what is the right vocabulary, the right vocabulary to use, so that it's consistent with the actions. Like, so for example, I regroup the 10 ones into 110. So the same thing, I regroup 10 ones into 110, so it goes into the tens column. So this is what the CPA approach is all about at the different stages. Now, this is a page, an example shown in our lower grade, grade 2. So you have a problem. The problem is modeled with the use of concrete objects. And then this model is then illustrated with diagrams, in this case, blocks. We call it the model drawing, or just blocks in this case. And then once there's understanding, that's when the last stage actually comes about. But this is the part where the activity comes in here at the concrete stage and at the pictorial stage. This is just to seal their understanding. At the upper grade, this is what we have. For example, what is 3/4 of 2? So 3/4 of 2, you would actually have got 2 oranges. You actually cut it into 4. So what they're experiencing is they're actually experiencing the real thing, quarters. I have 1 whole, I cut it into quarters, but I only want 3/4. So I will take 3 and I'll take 3 here. So I'll end up with 6/4. So 6/4, when I placed it, this is what I get. So this is the pictorial version, and then this is the abstract version. All right, so that's what we do for CPA, to actually bring about, like I said, to uncover or unfold abstract concepts to make it more palatable, more manageable for them to handle. The next thing that we adopted is, again, Jerome Bruner's spiral curriculum. Now, Bruner believes that learning takes place in first of all in stages, and not only that, Bruner says that key concepts are introduced to students at a young age, and these concepts are repeatedly revisited with increasing degrees of complexity as they grow into the primary school years. Now, what does that mean? Okay, so this is a simpler explanation of the diagram earlier. So it starts with a very simple, so look at the point 1. It starts with a very simple theme or a simple topic or a simple concept. Then the learning takes place right, and that's where they go through active learning, where they explore, where they discover new concepts, and then the aha moment kicks in, and then that's when practice comes in, a little bit of practice to sort of reinforce what they have learned earlier to reinforce what was discovered. So as they practice, they become better at it. And then it becomes like, duh, this is so easy. So with this new knowledge, that happens at this level, is then used to learn new things. For example, earlier on, I did the number bonds and place value. In order to do addition with the renaming, I actually tapped on two prior knowledge. One is number bonds, and the other one is place value. So I tapped on that again here. So whatever I've learned earlier, I tapped on it, and then I learned something more complex. You can see that it gets more complex because it gets, as you grow higher in grades, let's say, for example, grades 1, grades 2, grades 3, as it goes higher into the academic years, the level of difficulty increases. So for example, like addition, at grades 1, you have addition of tens and ones, and then grades 2, the idea, the concept of hundreds is introduced. And then as you go on, the concept of thousands, the concept of 10,000 over the years. So Spiral curriculum is a whole content strand that is broken down over the years, show that children learn, starts with a basic concept, and as they grow into the primary years, the concepts gets more and more difficult. The purpose of doing this, to spread it out, is actually to gain mastery. All right, the idea of learning is to understand, and not only to understand, to master the concept that has been taught. All right, by tapping on existing knowledge or prior knowledge and expanding it to make new knowledge. Now, the strength of this approach is basically the teachers do not really teach. The teachers plan activities for the children to discover. By doing that, what the teacher is doing is actually tapping on the child's prior knowledge, as opposed to the teacher telling them what the concept is all about. So in a spiral curriculum, you don't really do telling or layering of knowledge. In a spiral curriculum, we tap on prior knowledge, and then the children will actually discover with the teacher facilitating through questioning, facilitating through probing, giving clues, all right, to the children during the activities that are planned. Bruner believes that when you do this, when children discover the concept on their own using what they already know, their existing knowledge, it increases the responsibility to learn on their own, and it motivates them to want to do more. Because why? They start to experience success. All right, so when they know that, when they realize that they can do it, they are motivated to want to even do more. So these are examples taken from the MC Math. I'm just giving you an example of fractions. All right, so if you can see here, I'm looking at halves and quarters, but there are 4 learning outcomes here. All right, but I just want you to focus on this one here. I'm trying to explain to you how spiral curriculum is actually embedded in our books. So let's look at the last LO here, recognize and find house. So at grade 2, what the children are supposed to do is just to recognize and find house. And then at grade 3, you can see that using this as a prior knowledge, I'm going to tap on the knowledge here. I'm going to expand it to find equivalent fractions of half. All right. Now, at grade 4, I'm going to tap on equivalent fractions so that children would be able to recognize and find other equivalent fractions, not only restricted to half, but all other equivalent fractions. So you can see how it opens up. So every objective has a purpose, because I could actually look at the objectives and ask myself, if I'm going to do equivalent fractions of half, what must the children know before I start teaching them equivalent fractions of half? So this is exactly what they have to know. They have to recognize what is a half, first of all. And then later on, I could expand it. So let's take a look at this, all right? So again, so this is an example of a grade 2 book. All the exercises found in the book about finding halves and writing halves and what it's all about. So there are activities here, and there's explanation And then there is this thing again towards the end of the chapter. Now, if you look here, there are 4 cubes in a box. So this is a quarter. Or if I take 2 out, I actually have half and half. So in this case, they move on in terms, like I said, the level of difficulty is very gradual. They start half with having 2 equal parts only. But can you see that? 2 equal parts here. Okay. As they move, you can see that even though there are 4 parts, I could actually get 2 equal parts out of the 4 parts. I could make 2 equal parts. So in this case, I could just get half of this instead of 4 parts. I could use 2 parts. But that, if you look at the pages, it's towards the end of the chapter. Okay, so all these idea that they have learned, all these concepts that they have learned will then be used as prior knowledge in a grade 3 classroom the next year. Because okay, let's just do this again. Sorry, let's go back to this. So if they are the teacher, the grade teacher is going to start teaching equivalent fractions of half. What they would need to do, what the children would need to recall is the children would need to recall what is a half and what is a quarter. Remember, in this case, a half, by right, we started off with 2 parts, but over here I have 4 parts. So the children would need to know that there are 2 equal parts, although it's broken into 4. Okay, this is a prior knowledge that is being tapped on at the grade 3. And this is actually done in grade 2. So at the grade 3, we're now finding equivalent fractions. So they start recalling, for example, which shapes are half shaded. So they need to identify which one is actually half. And then there is an activity for them to discover equivalent fractions of half. So you have a strip of paper here that is folded into 2. All right, and then that's half. So what happens if each side is further folded into half? Then you get quarters. What happens if each side here of the half is folded into 3s? Then you would have 3 folds on one side or 3 parts and then another 3 on the other. That would be 6. And that's how they generate equivalent fractions of half. So then it's followed by this one here. All right, so this is page 208, this is page 209, so the 209. So there is this fraction strip that talks about half folded into 2 parts. This is where the half is folded into 3, and this is where the half is folded into 4. So with following this activity would be this chart here to reinforce what they have learned. So at grade 4, so once the children have understood how to generate equivalent fractions, if you notice at grade 3, we are not quick to introduce the use of multiplication. All right, so multiplication in finding equivalent fractions. Like I said, you do activity to make sense of what it is. So in grade 4, we are finding other equivalent fractions. So there will be equivalent fractions of quarter. 1/4 is 2/8. 1/5 is 2/10. So then they recall on what was done in the earlier previous grade. So half is actually equivalent to 2/4, where they folded twice, they folded 3 times, and then they folded 4 times. And these are the equivalent fractions that was discovered last year. So in the next academic year, in the grade 4, that's when they start introducing multiplication in equivalent fractions, not immediately at grade 3. At grade 3, the focus was very much on tapping of previous or existing knowledge to make sense of what's going on. And then the children will then see, like, actually it is a multiple of from here to here is a multiple of 2, this is a multiple of 3. And then for the rest of equivalent fraction, that's when they start using the rule. This is a rule or an algorithm, like I said, which we only learn a procedure at the end, not at the start of the lesson. And then they go on to transfer that learning in more complex situations in grade 4. All right, so we move on to the next one, which is problem solving. Polya, we use Polya's framework in problem solving. So Polya says that solving a problem is actually finding a way out of a difficulty in which a solution is not immediately available there and then. They have to go about to find the solution. And to do that, the children will need to know ways of solving. In this case, it's called heuristics. So this is the Cambridge CAIE framework. So these are all your constraints of number, geometry, measure, and handling. And then you see this particular part here, problem solving. So Cambridge give focus on problem solving uh, um, as important as the rest of the constraints. Okay, so you can see that problem solving is central in the framework, in the CIE framework. Now, what actually goes into a mathematical problem solving? Two things. The child must have the conceptual knowledge, all right, of the mathematics that he's doing. For example, 1/3. What is 1/3? The concept of fractions. The child must know that. And the child must know the ways of solving the problem, the techniques, the different techniques. Now, what are the techniques that we have here? Now, this is used in a typical Singapore classroom, but it's very much modified in our Cambridge books. Um, it's slightly different because back here the rigor is really strong. So if you look at it, these are all the heuristics that we use, age specific. So at grades 1, we do part whole and comparison. We only do before and after in grades 5 and 6, together with working backwards, grades 5 and 6. All right, so it's staggered over the years so that the children would be able to slowly uh, understand and understand and use them, apply them. All right, so we when we talk about problem solving, children tend to get the two mixed up between problem solving and solving problems. Solving problems is basically when you're given a problem, they will then immediately write the numbers added together to give you the answer, and then they get the total subtracted with a certain number to get to the answer. All right. So what they're focusing on is very much on rules or algorithm or procedures. But in problem solving, the emphasis here is on thinking, is on developing flexibility in thinking. Flexibility in the sense that you are able to look at it from different perspectives. All right. Looking into creative thinking. We're looking at the use of heuristics. We're looking at the use of mathematical concepts and ideas and skills like deducing, uh, inferring, right? So when earlier on I mentioned George Polya, now in problem solving, George Polya gave us this framework when it comes to problem solving. So there are 4 principles. The first one is when you have a problem, first of all, you must have is an understanding. You must have a complete understanding of the problem. It's not about doing it immediately to get to the solution, which is what the children usually do. They just want to get it done, finish it off, and then get the solution. Over here, the focus is not on the solution at all. The focus here is on the process of problem solving. So we start with the first one, reading for understanding. All right. So how do we know we have understood? So the child must be able to reinstate the problem in his own words. Say it in your own words. Draw it. Tell me how you understand the problem. Describe the problem to me. Once that is done and you're happy with it, then you move on. Okay, so now that you've understood the problem, how are you going to solve it? What's your plan? So remember the heuristics that I used? So one of them, the child should be able to do it, to use it, to apply that, to learn. Now, so so in this case, a heuristics, you must think of a heuristics, a way to get to solve that problem. So once you have that plan, you have to carry it out, do it. All right, the last step is, again, it's not the answer, it's whether, how do you know what you have done is actually correct? And that's when, at this stage, the children start reflecting on, did I do it correctly? Or does the answer make sense? How do I know the answer makes sense? What can I do? Do I use an alternative strategy here? At this point, do I solve it using a different planning? Do I use an alternative strategy? and then see if the answers are similar, or do I substitute the answers back into the question and see whether everything tallies? So like I said, if you look at the 4 stages or the 4 principles, none of it focuses on the answer. A lot of it focuses very much on the processes. All right. So the answer is very, very secondary. So these are examples of problem solving, very simple, the use of bar modelings. All right. Now, remember I mentioned the word flexibility in thinking, where I said something about the difference between solving problem and problem solving. I spoke about flexibility. So if the child is so used to be given a problem, all right, and then they are supposed to come up with a solution. So in this case, what we want to do is we would like them to create their own problem, make a problem of your own. So that's when they have to step out of their usual zone, the comfort zone. And then because they're not solving the problem anymore, there is no problem to solve, because right now what we're doing is that we're creating the problem. And in order to create the problem, then they have to solve it, because then they know, like, oh dear, I can't solve this problem because I think I created an incorrect problem. So we go a level higher than that. Another way is, not only are we asking them to create a problem like that, if you think this is very difficult because they can't do it, the children cannot make sense whether they actually do the right question or not, then start simple. So what you do is, if you look at this, I am very sure straight away you can come up with a problem, and you can say that there are 16 more red marbles than blue. Altogether, there are 20 marbles. How many blue marbles are there? So if you think it's difficult for them to start with this, start visually first. All right. So again, like I said, when you give this variation, this type of helping them to create a problem, it becomes a lot easier. And when they're familiar, that's when you start just giving them words and numbers. And by that time, they would have enough practice to be able to do this correctly. So this is another other examples of problem solving that promote, actually, they're a bit challenging. So we've got 3 ropes, which is the longest, so this is easy. The part B is the part that gets everyone thinking. Can rope Q be longer than rope P? All right, so I leave you to decide. What I like about this is, if a child says yes, justify. If a child says no, then justify, because both answers could be correct. All right, a yes could be correct depending on the justification or the reasoning or the argument. And a no could also be correct depending on how the child reasons to this question. The next one is draw 2 ribbons. Draw a longer, the longest and the shortest. So you can see, what I like about this is you can see the creativity of a child here. So the usual draw a longer ribbon, and then another one which draw a shorter ribbon. That's really good. That shows they have understood. But I've seen examples where they color this yellow. So this is the longest ribbon, and then you have a slightly shorter one, and you have the shortest ribbon below. And that's when you know this child is really creative. All right. So then this is, again, flexibility, all right? Show me an improper fraction pictorially, all right? Any improper fraction. So they must know that this is actually one whole, and this whole is made up quarters. So this can be done at the start or the introduction of improper numbers and fractions. And then this is another example of bearings. That requires the children to actually sit and think of, how do I go about getting a solution to this problem using Polya's 4 stages of problem solving. The next part is, we talked about model method. So for the model method is actually translating a word problem into pictorial representation. All right, that's just about it. Translating words into pictorial representation. For example, like this, I gave 8 stems there altogether. I have some stems. I gave 8 to Charlie and I have 12 left. So the reason why it's called part whole is because this is a whole, what I have at first, and these are 2 parts here. So how much do I have at first? So it's easier. You can see straight away from here that I actually have got 12 and 8. I've got 20 altogether. This is done in the upper grades, for example. It sounds really, really daunting for a child, but believe me, it's actually easier when you use a pictorial representation, in this case, model drawing. Aini had some money at first. She spends 3 out of 5 parts. So they're all together here, 5 parts, but Aini spent 3 parts on Monday, and then 3 over 10 of the remainder. So you can see that this is the remainder. There are 2 parts here. The remaining parts are 2, but she spent 3 out of 10. That means I must actually break these 2 parts or divide these 2 parts into 10 parts like this. All right, so you can see that spend 3 parts on Tuesday and is left with 7 over 10. Originally, this is just 2 parts here, and I subdivide it into 10 parts like that. So once you have it laid out like that, it's easier for the children to actually visualize the problem. All right. Now, to get to this stage, the children need to understand the problem, because once the first part, remember Polya's first part, as long as understanding is there, they can start sketching the model. After the father gave her another $162, she had the same amount of money she had at first. So this amount of money was gone, right? This amount of money was gone. She was left with only the yellow parts. But after the father gave $162, she had the amount she had at first. So you can see that each part was subdivided by 5. So you have 5, 10, 15, and then you have 8 parts here. 15 plus 3 is 18 parts. 18 parts represents 162. All right, so this is a grade 1 lesson. If you look at it, it's quite wordy, but actually it's very simple. So what we do is we read sentence by sentence, get the children to read sentence by sentence so they understand what each sentence, the information that each sentence offers. So William had 5 fewer colored pencils than Zoe, so that's easy to see. William has lesser, Zoe has more. And then Zoe, we talk about Zoe and Serene. Zoe has 10 more, so Serene is even shorter, so 10 more. You can see that this is 10 here. So based on the diagram, you can already see how many more colored pencils did William have than Serene. So you can see that how many more does William have? Straight away, you can see the answer is 5 without having to actually work out the problem. The emphasis or the focus of problem solving, the most crucial part is the understanding bit. So once the understanding is there, once the children starts doing it, it comes. I wouldn't say it comes naturally, but once they start writing, they start working it out. That's when the motivation starts actually, and when when they are stuck, and that's where scaffolding comes in from you or from the peers. If you, for example, this can be done in a group activity. All right, so this is this is what we call the comparison model of multiple concepts. So for example, like this, Peter, twice of Peter is half of Susie. So this is actually Peter's actual, but we're saying that twice of Peter, but Peter actually has 1 part. And this is Susie's actual part, because 2 times of Peter's is actually equals to half of Susie's. And altogether they have 180. The red line shows that 2 parts of Peter is actually equals to half part of Susie. All right. So you can see that 180 is actually what they have. 1 part of Peter and 4 parts of Susie. And then this is, like I said, in the upper grades, the before and after. Abdul and Khan receive the same amount of salary. There you go. Abdul spent 3 times. So this is Abdul spending 3 parts of his money as compared to Khan. The amount of money Abdul has left is naturally lesser. Abdul is left with lesser money. Khan has more because he spent less. The amount of money Abdul left was 170. Where is 170? You can see that Abdul is lesser, Khan is more. So 170 would be this, right? Abdul would have lesser by 2 parts, and these 2 parts would be $170. So these are examples from our book, the part whole, and then the comparison using the multiplicative concept, and then this one, the comparison using the additive and subtractive concepts. So we've come to the last part here, which is on mastery. Like I said, when we teach, the idea is to get the children to bring about, to achieve mastery, to bring about understanding so that mastery is achieved. Now, mastery comes in 3 forms. You could do this in your classroom. It comes in a form of practice, comes in a form of review, and transferring that learning to new situations. So we call it extended learning. So this is like what it says, practice. All right, practice includes repetition and variation in terms of level of difficulty, in rephrasing the question, same concept, but rephrased differently. All right, so all this will be included in the practice part. The next part is the review. Review is where a child takes ownership of their learning. All right, they take accountability. So for example, like they'll go like, I have learned, I can count on and count back. Do I agree? Not sure, or no, I disagree. And then if you disagree, go back to this page, to the pupil's book on section A, and relearn that part of the topic. All right. So this is actually for them to monitor their learning. And then when they write their notes here, when you come to the teacher, the facilitator, when you come to this page, then you know like, okay, this child has problems at this point here, and I'm going to follow up with the child. All right. So then the next part here, this is a grade 6. This is on statistics, on median. All right. So justify your answer. Again, reviewing, reasoning, justifications. All right. Extended learning. So this is extended learning usually requires them to it requires them to be able to transfer what they have learned to do more challenging tasks that stretch their thinking and to deepen their understanding. So this is an example of a Venn diagram, all right? And this is for them to actually think given the restrictions of the problem here, the question. All right, so with that, I end